Today we're talking about right triangle congruence. We're going to prove right triangles are congruent using HL. HL stands for hypotenuse legs. So if you know the lengths of two sides and the measure of a non-included angle, it is sometimes possible to create two different triangles. So this would be an example of SSA. SSA is not a valid method for proving the triangles are congruent. However, this method will work in right triangles, where the right angles are the non-included angle. In a right triangle, the sides adjacent to the right angle are called legs. For example, here and here, these are the legs. And the side opposite the right angle, so if we find the right angle here and go straight across, this is called the hypotenuse. Hypotenuse leg congruence theorem, or HL, is if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. To use the HL theorem, triangles must meet three conditions. There must be two right angles. The triangles must have congruent hypotenuses. And there must be one pair of congruent legs. So we are going to say which postulate or theorem we would use to prove the triangles are congruent. Now, both of these, in both cases, we have a hypotenuse and a right angle. So looking at number one, we have a right angle here. We have a leg here that is the same on both of those triangles. And then if you look at each hypotenuse, it has two of these same pieces. So this one would be congruent by HL because it has a right angle. The hypotenuse is the same. They both have two ticks on the hypotenuse, and one of the legs is also the same. So, but number two, it's a right angle, but if you notice, we don't know anything about the hypotenuse, so it's not HL. We do have a side, another side, and then the angle in between. So this would be side, angle, side, two sides with an angle in between congruence. Now, it's saying all of these, if these are congruent by hypotenuse legs, so we have a hypotenuse that's the same and a leg that's the same, for what values of x and y are the triangles congruent? So let's look at number 3. If we have the legs are the same, then x plus 1 has to equal 5. For the hypotenuse to be the same, 2y plus 1 has to equal 7. So on the first example, we're going to minus 1 from both sides. So x is going to equal 4. And for the 2y plus 1 equals 7, we minus 1 from both sides. So 2 times y is 6, so y has to equal 3. On example 4, we're going to take our hypotenuse and make them equal to each other. So 3x equals y plus 1. And then our legs are also going to be the same. Y equals x plus 3. Now, if we were to take either of these individually, we could not solve it because it has both an x and a y. So what we're going to do is we're going to use substitution. We know y equals x plus 3. We're going to take that x plus 3 and substitute it into the y of the other equation. So we will have 3x equals x plus 3 is going to go instead of y, and then we add our 1. I see a 3 and a 1 on both sides of the equal sign. So x plus 4 equals 3x. I want to get the x's together. I'm going to minus an x from both sides. 3x's minus an x is 2x equals 4. Divide by 2. And since 2 times 2 is 4, x equals 2. Now I also need to figure out what the y is. I'm going to take this 2 and substitute it into the x of the other equation. So y equals 2 plus 3, so y equals 5. For example y, I have 2 legs, y equals x minus 5, and 3x equals 2y plus 24. Now, both of these have an x and a y, and so I can't solve one of them on its own. I've got to put them together. I know that y equals x minus 5, so what I'm going to do is I'm going to put an x minus 5 into the other equation, and so I'm going to rewrite 3x equals 2. My y is x minus 5 plus 24. Keep in mind that 2 is being multiplied by the y, so I want to take that whole x minus 5 and put it in parentheses. I'm going to use the distributive property here to times out that 2. I'll have 3x equals 2x minus 10 plus 24. Let's minus 2x from both sides. So x is going to equal 24 minus 10 is 14. Now x equals 14. To figure out what y is, I'm going to take 14 and substitute it back into the original. And so I'm going to put my y equals 14 minus 5, which equals 9. So x is going to equal 14 and y is going to equal 9. For number 5, I have to show 3 things. First, I have to show that we have the hypotenuse, or that they are right angles. They both have right angles. We have to show the hypotenuse are the same. We also have to show some legs are the same. Let's just put an outline. We're going to show we have to have 2 right angles. We have to have a hypotenuse. We have to have a leg. And then we have to show that the triangles are congruent. So our first one is given. ABD and angle CDB are right angles. We also are given that the hypotenuse of both of these triangles are the same. AD is congruent to CB. That is also given. Now the leg is going to be this reflexive line here. So BD is going to be congruent to DB because of the reflexive property. So now we're going to use our final triangle ABD is going to be congruent to triangle CDB by HL congruence. Number 6, we know that LO is perpendicular to PN. This is going to be some extra info there. PL is going to be congruent to NO. That is our hypotenuse. And then our leg can be given because M is the midpoint. These are the 2 legs. So first we're going to give our the given information. We have to show that we have 2 right angles. We have to show that we have 2 hypotenuse are the same, are congruent. We have to show that the 2 legs are congruent. Then we're going to write our congruency. Now, it's not asking us to show the triangles are congruent. It's going to show that we're trying to show that angle L is congruent to angle O. So that's going to be our corresponding parts of congruent triangles have to be congruent. So this is kind of an outline of our proof here, and then we're going to go ahead and write out the actual information. I'm going to start with LO is perpendicular to PN. That is given. But that we can show that angle LMP and angle OMN are right angles. That would be the definition of this symbol right here. That means a perpendicular. These two lines are perpendicular. And perpendicular means that they make right angles. So we've shown that these two are right angles. We're going to show that the hypotenuse are equal. That is given. PL is going to be congruent to NO. Now we're using the definition of midpoint. I need to write that as extra information. I didn't write it earlier, so I'm just going to kind of put it up at the very top. M is the midpoint, and that is also given. So the leg PM has to be congruent to NM, and that would be because of the definition of midpoint. Okay, now we're going to show the triangles are congruent. Triangle LMP is going to be congruent to triangle OMN by HL congruency. But we're not trying to show the triangles are the same. We're trying to show that angle L is congruent to angle O. And if those two triangles are congruent, then the corresponding parts of congruent triangles have to also be congruent.